So, ladies and gentlemen, today we are going to delve into some more inverses. So we talked about inverses in our 6-7 notes, and then today we are going to figure out the inverses of some of our old friends. So the first one is square root. Now, hopefully you know that square root is the opposite of squared. So as we do this, you might start to go, hey, that sounds familiar, but not exactly. So when we graph a square root, we actually graph the inverse or opposite of a quadratic. So normally when we graph a quadratic, we go right 1 up 1, then we go right 2 up 4, and right 3 up 9. But if you'll notice, 1 1 doesn't really switch, but if you notice these ones, they're backwards. So you might know from that being backwards that square root is the inverse of squared. So let me just show you. Let's just sketch a little graph of this. So we need to go right 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 1, 2, 3. Okay, so my start point is 0, 0. So here's my start point of 0, 0. And then I go right 1 up 1, right 4 up 2. So always going back to this start point, right 4 up 2, back to the start point, right 9 up 3. And that is all, and it says that there are no extra points, So this is all we've got going on for this graph. We like to call it the eyebrow because it just kind of has one little eyebrow thing going on. So let's talk real quick about domain and range of this thing. Well, domain is the x value. So if I take my pen and I go along here, I don't hit my eyebrow until here. So this right here is where I first hit my eyebrow. So that is 0. And then my eyebrow goes on forever for this arrow. So my domain is always x, so I put an x, and it's greater than or equal to 0 because it starts at 0 and goes on forever. Now my range, to do this, I put my pen sideways and I move up and I hit my eyebrow right there. So at this point is where I hit my eyebrow. So I have a y and I have 0, and then it goes up again to an arrow, so forever, so y is greater than or equal to 0. It's greater than or equal to because I actually have the point 0, 0 on my graph. So 0, 0 is my start point. It shows up again in my domain and range. You'll notice that as we go further. Okay, so then we have some transformations on that one. If we have a -1 out front, it multiplies these ups by -1, which would make your eyebrow kind of down like that. Instead of going up like normal, it goes down. A stretch or compression, a stretch can make your eyebrow tall. A compression can make your eyebrow more flat. Shift right and left moves your start point, so it can move it all over the graph. And then if you say, let's move it, moved it here, then we just have our eyebrow starting here. So right and left, remember, are inside the parentheses. Plus is left, right is minus. So inside the parentheses, in this case, under the radical is your right and left. And then after the parentheses, or in this case, outside the radical, moves us up and down. Okay, so vertical, outside the radical, horizontal, inside, and those things change your start point, this 0, 0. Okay, let's talk about cube root. So if square root is the opposite or inverse of squared, cube root is the inverse of cubed. So I don't know if you remember that little squiggle that we did, but here is the opposite of that squiggle. Okay, so here we go. Draw a little graphy graph. 1, 2, 1, 2. That's all we need up and down. 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Go 2 up and 2 down, 2, 8, and 2 right. So on this one, we again have a start point of 0, 0. So there we go. Then we go right 1, up 1, back to the start, right 8 up 2 back to the start. And we could go right 27 up 3, but I'm not going to try to graph that. On the left side, we go left 1, down 1, left 8, down 2. So just the inverse of that squiggle where we did right and up, left and down, except this time on our x cubed, we went up a lot further, and on these ones, we're going to go right and left a lot further. So it's kind of like the eyebrow, but it has this side because we can do negatives under a cube root, whereas if we do negatives under a square root, we get imaginary. So that's why it has this side, and square root does not have that side. Okay, so cube root, let's talk about its domain and range. Okay, so its domain and range. If I'm looking at domain, I do x values, so this way. Oh, I got an arrow, so that means all the numbers this way, so negative infinity. And clear over to here, another arrow, so all the numbers that way, positive infinity. So that's going to mean all real numbers if I'm going from negative infinity to positive infinity. Or if I'm soups lazy, I can just draw this capital R and then make a vertical line through it, kind of like a $sign, but with only one line. Okay, range. If I'm at the bottom, I have an arrow. At the top, I have an arrow. So range is going to be the same thing, all real numbers. Or again, if we're lazy, the R with a vertical line through it. Same thing here. If we have a negative out front, that multiplies our ups and downs by -1. So if we had this going on, it would actually start up top and go down low. Okay. Multiplying the ups by A, that can stretch it. So it can kind of have a stretch, or it can compress it. So, oops, I'm doing those reflected. It can stretch it or it can compress it. So stretching would be kind of a bigger thing in there, and compressing would be kind of just a smaller curve in there. And then right and left are inside. Right is negative, left is positive, and up and down are outside. Plus is up, minus is down. So let's go graph some of these. Flip it. Okay, looks like we've got 4 of them to graph, and we don't have any graphs, so we're going to have to draw them. So first of all, I need to figure out which one this is. So this one, is it a square root or is it a cube root? Well, a cube root will have a 3 here in the index, the armpit of the radical. So this is a square root, which is the eyebrow. That's the one that's only going to have one side to it. So now I need to look, does it have any transformations? So let's look at our transformations. So do we have transformations? Yes, we do. Anything that's not just square root is a transformation. So it looks to me like I have a shift down 3. So here, that is a shift down 3. So down 3 is going to change my start point. So my start point was at 0, 0. If I move it down 3, now it's at -3. So if I draw in my graph here, oh, do I have any other transformations? I don't have anything in front or anything underneath. This 3 is all I have, so shift down 3, that's all I've got going on. So that just changes my start point. Okay. So went down 3, up 3, and right 9. Okay, so my start point now is at 0, -3. So it was at 0, 0. I moved it down 3. So it's at, oh, sorry, you couldn't see that. It was at 0, 0. I moved it down 3, 0, -3. And now I use my same right 1, up 1, right 4, up 2, right 9, up 3. Where did you get those, Mrs. Black? Well, they gave them to me on the front, but also if I take 1 and take the square root of it, that's 1. If I take the square root of 4, that's 2. If I take the square root of 9, that's 3. So that's where those numbers are coming from. So from my start point, I'm going to go right 1, up 1. Then go back to my start point, go right 4, 1, 2, 3, 4, up 1, 2. Back to my start point, over 1, 2, 3, 4, 5, 6, 7, 8, 9, up 1, 2, 3. There's my eyebrow. Draw that in. Okay. Remember, it has an arrow on this side, but not on the start point side. Then domain. So domain, if I put my pen down and move it across, I hit my graph or my eyebrow right here. So domain is X. Well, this is the point that I hit. What's the X value of that point? 0. And then it's to the right or greater than 0. Range, same thing. Start at the bottom, move up. This is the point I hit. Range is always Y. From this point, I steal the Y value, -3. And then is it above this point? Yep. So I use greater than or equal to. It's or equal to because my graph actually touches that point. Okay. Graph, give the domain and range. Done. Okay. Next one. On the next one, I have a lot more going on. Okay. So a lot more going on. So first we need to figure out if this is square root. We're also going to list the transformations. List the transformations of each of these. Okay. Is this cube root or is it square root? Well, without that 3 in the index, I know that this is square root. So that tells me which from the front of the overs and ups. I'm going to go over 1, up 1, over 4, up 2, over 9, up 3, as opposed to cube root, which has the 2 and the 8 in it. So square root, so I've got that going on there. Okay, so this negative right here, I'm going to start at the front and move to the back. So this negative is a transformation. That is a reflection over the x-axis. That 2 is something else. That 2 is something else. It is either a vertical stretch or a vertical compression. Do you know which? Hopefully you know that it is a vertical stretch. If you're not sure if it's a stretch or compression, think of your favorite number and multiply it by this. If it gets bigger, it's a stretch. If it gets smaller, it's a compression. So a vertical stretch of 2. Okay, and then it looks like under here I've got a 3. That 3, being underneath there, is going to shift it right or left. Which one do you think if it says minus? Hopefully you know that that is a shift to the right, 3. And then the +4 up out here shifts it up. Hopefully you knew it was up, 4. So inside is right and left. It does the opposite. Outside is up and down. It does what it says. Okay, so where's my start point going to be? Where is my start point going to be? Well, to find the start point, I do opposite of what's inside the parentheses. So it says -3. I went right 3, so I do 3. And then I do what the up and down says. So 3, 4. So when I draw my graph, I'm going to start it at 3, 4. I'm going to draw my graph in here, putting this y-axis kind of to the left. I need to go out quite a few. Let's go to 12 and see if that gets it. One, 2, 3, 4. 2, 4. Okay. We'll actually put some numbers on there this time. So my start point is at 3, 4. So I'm going to go right 3 and up 4. There's my start point. So then my normal pattern for growing is over 1, up 1, over 4, up 2, and over 9, up 3. Now, what is going to change this? Well, my reflection over the x-axis multiplies all the ups by -1. So multiplying them by -1, in effect, makes these arrows go down instead of up. Okay, and then the stretch of 2 is going to multiply them all by 2. So I'm actually going to go right 1, down 2, right 4, down 4, and right 9, down 6. So all of these got ups and downs. The ups turned to downs because of the reflection, and they all got multiplied by 2. So I am going to go right 1, position myself better, right 1, down 2. Then go back to my start point, right 4, down 1, 2, 3, 4. Then right 9, hopefully I have enough, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh good, it's above the 12. Down 6. 1, 2, 3, 4, 5, 6. So there's my graph, my eyebrow. Okay, so because of that stretch, it doesn't go up this time. It goes, oh, sorry, not because of the stretch. Because of that reflection, instead of going up, it's going to go down. That also is going to change our domain and range. Our domain and range is going to change quite a bit. Okay, so domain, we know is going to be X, and range, we know is going to be Y. So when I do my domain, I move from left to right. This point is the first thing I hit, so I steal its X value. Now, are the X's of my graph larger than 3 or smaller than 3? Well, they're on the right, so they're larger, so we use greater than or equal to. The range, though, I start at the bottom and, I have an arrow. So let's go up to this graph, or this point. So from this point, it's all these numbers down here, right? So I'm going to steal the Y value from that point, and it's going down. So it's negative infinity, or smaller than 4. So I'm not going to use my greater than sign here. I'm going to use a less than sign. Okay, so a reflection not only makes your graph go down, but it changes your range to use a less than sign, because the range values are 4 and smaller, 4 and less, so less than 4. Okay, a couple more to graph. Let's switch over to this one. So is this still a square root? It is not. It has a 3 in the index, so that tells me it is a cube root, which sometimes we call the sideways squiggle. Since we called the cubic the squiggle, this is the sideways squiggle. Okay, let's list our transformations. So first comes this negative. That is a reflection over the x-axis. Okay, and if you can't remember those, you can flip back to this front page and see that a negative looks here, and it says a reflection in the x-axis. Okay, so a negative there is a reflection in the x-axis. That's where I'm getting that. Okay, so I've got that negative. Cube root of x is not a transformation, but this plus 4 is. How is that 4 moving it? What do you think? Hopefully you know that that is a shift up 4. Okay, so it also said that my reflection changes my pattern. This, though, changes my start point. So my start point for these is normally 0, 0, but if I make it go up 4, now it's 0, 4. Okay, so if we draw our graph in here, these ones are long, so draw really long, try not to get into my other one, and I've got to go up 4, so I need to go up at least 4, 1, 2, 3, 4, 5, 6. Let's see if 6 will get it. Let's go 8 on both sides. So up to 6 and 8 on both sides. All right, so my start point is 0, 4. So that's over 0, up 4. Now my normal pattern for this one is right 1, up 1. Right 8, up 2. And then on this side over here, it's left 1, down 1. Left 8, down 2. However, this reflection, just as it did up here, is going to change all my ups and downs. So on the right side, instead of going up, I'm going to go down. And on the left side, instead of going down, we're going to go up. So just wherever your arrows were, it switches them. So here when I go right 1, I'm now going to go down 1. Go back to your start point. When I go right 8, I'm going to go down 2. On the left side, when I go left 1, I'm going to go up 1. And when I go left 8, I'm going to go up 2. There's my new graph. So that is the same sideways squiggle, but it's been moved up 4 and then reflected. So let's talk about domain and range for this guy. So the domain and the range on the sideways squiggle actually never, ever, 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 ever changes because there's nothing I can do to it, no shifts or stretches or compressions that'll change these ends from being arrows or for including all the numbers ever. So the domain and range for every single cubic is always, 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 always all real numbers. Let's try this next one. I would like you to pause this video and see if you can list the transformations. I'll give you a hint, there's 3 of them. Welcome back. I hope you took the time to actually pause the video and try to do this on your own, but let's see what's going on. Okay, so we need to look immediately after the equal sign. I don't have a negative, so no reflection, but there is this 1/4. So 1/4, that's either going to be a vertical stretch or a vertical compression. If I multiply something by 1/4, that makes it smaller. So this is a vertical compression of 1/4. And then the 5 being inside is going to move me right or left. Which one do you think it is? Hopefully you know that that is going to move us, a shift right 5. And then that -3 is going to shift us down 3. So 2 of those things mess with my start point. Which 2 mess with my start point? If you said the shifts, you're correct. The shifts mess with your start point. So my start point was 0, 0, moved it right 5, so +5, and moved it down 3, so -3. So when I draw my graph, I'm going to have to start at right 5, down 3. So now I'm going to have a lot of this on the right-hand side. So let's put our y-axis right there. Let's go out 1, 2, 3, 4, 5, 6, 7, 8, 9, 13. Let's go to 14. Go down 5, up 2, and left 4. Okay, so let's draw in that graph. So if my start point is at 5, -3, from 0, 0, 1, 2, 3, 4, 5, down 1, 2, 3. There we go. So my normal pattern for growing on this is right 1, up 1. Oh, let me move that over. My normal pattern for growing is right 1, up 1, right 2, nope, right 8, sorry, I started to do cubic, right 8, up 2, and right 27, up 3, but we're not going to get that one on there. And then left 1, down 1, left 8, down 2. Okay, so I've used my right and my down, but I haven't used this vertical compression. So what down here does the vertical compression change? Hopefully you remember it multiplies your ups by whatever it is. 1/4 times 1/4. So multiplying by a fraction is the same thing as dividing by its, well, we can just multiply. 1/4 times 1 is 1/4. 2 times 1/4, I would do 2 times 1 and get 2. 2 divided by 4. So now I have 2 over 4, which simplifies to be 1/2. Okay, so I'm going to go up 1/4 and up 1/2. This is going to be interesting. I'm trying to do these fractions. Okay, so I'm going to go right 1 and up 1/4, left 1 and down 1/4. Then we're going to go right 8. 1, 2, 3, 4, 5, 6. Oh, I messed up. 1, 2, 3, 4, 5, 6. Nope. 7, 8. So to 13 and up 1/2. And then over here, I'm going to go left. 1, 2, 3, 4, 5, 6, 7, 8. So to -3 and down 1/2. So as you see when you draw this in, there's not much of a curve in it. There's really not much of a curve in it. Okay, so it's pretty flat here. Then to lastly, but not leastly, do the domain and range. Hopefully you know what the domain and range is. It's all real numbers. And that about wraps it for graphing these. Tune in next time for more wonderful worlds of maths. Good luck on your assignment. Let us know if you have any questions.